Geometry, Unit 12, Section 5, dividing segments proportionally. Depending on what year you're watching this video, this may no longer be 12.5, but it is dividing segments proportionally. I may move this section over to Chapter 11. Um, so that might be incorrect for you, but dividing segments proportionally. So first thing is, this is our first look at the midpoint formula. And the midpoint formula is just kind of introducing something here that we're actually going to go more advanced than the midpoint formula here to a technique for dividing segments proportionally. But the midpoint formula is not really the focus of this video, but it is very, very important formula. We're going to use this formula a lot um, later in Unit 12 when we are proving parallelogram properties, improving, just geometry properties in general with coordinates. If I want to prove something is a parallelogram, I could show the diagonals bisect each other by having the same midpoint. So the midpoint formula joins the slope formula and the distance formula as like our core coordinate formulas along with the point slope formula, things like that. But this is an important formula that we're just going to touch on a little bit here, but it becomes very valuable later. And it's probably the easiest formula we have. One thing about the midpoint formula is the only formula that we add the x's and the y's together. You think about slope and distance, like there's always x2 minus x1 or y2 minus y1. Midpoint's the only time we add them. And so the midpoint formula is simply add them up, divide by 2. So add the x's, divide by 2, add the y's, divide by 2. So determine the midpoint of AB with endpoints, and these didn't get typed in here, with endpoints of A, which is negative 6, 3, and B, which is 2, negative 1. And you see that here on the graph. And so the midpoint between these is the formula is simply add them up, divide by 2. And you could do, negative 6 plus 2 over 2, so on. But I think a lot of times you could kind of just, in your head almost say, all right, what is this divided by 2? Add them up, divide by 2. But I'll show the math out here. Negative 6 plus 2 divided by 2, and 3 plus negative 1 divided by 2. And so that would be negative 4 divided by 2 and 2 divided by 2. And that's going to ultimately give us the coordinates of negative 2, 1. And you kind of think, all right, negative 6 plus 2 is negative 4, half that's negative 2. 3 and negative 1 is 2, half that's negative 1. So the point is negative 2, 1. And graphically, it does look like it is, I'll put an M there, in the middle of the segment AB. If I draw the line connecting segment AB, which is always a good idea to do anytime you're working with two coordinates, draw the line connecting them, I can see that. There is another way to do that, of course, other than adding them up, dividing by 2. What we could do is we could kind of cut the step in half, I call it. Like, what is the slope from A to B? And so now we're using our slope formula, and the slope formula is y2 minus y1 over x2 minus x1. And so that would be the second y value. And we always go, we list them as left to right. So this would be considered the first point, and this would be considered the second point. And we do second minus first, or right minus left. So negative 1 minus 3, negative 1 minus 3, and 2 minus negative 6, 2 minus negative 6. And so that means it's a negative 4 over 8. And just think about that unreduced for a minute. Keep it negative 4 over 8. What that's saying is go down 4 over 8. Now that simplifies to negative a half, negative a half, negative a half, negative a half, down 1 over 2, down 1 over 2. That works too. But if you think about just the one giant step, the unreduced slope formula gives me how much I go down, how much I go over. Well, midpoint is halfway down the line. So if we take this unreduced slope and we just do half of it, half of negative 4 is negative 2. So we go down 2. And half of 8 is 4. So instead of going over 8, we go over 4. And that would also bring us to our midpoint here. The reason why I show you this other method is because this is ultimately what we're going to do for when it comes to dividing segments proportionally. Before we get to proportions here, how about finding the coordinates of the point that's a fourth of the way along AB closer to A? Now, on the graph, you could probably tell it's just going to be this point. It's a fourth of AB, and it's closer to A. We could use the midpoint formula again. Now that we have the midpoint here, negative 2, 1, we could find the midpoint of this half, because half of a half is a fourth. And so you could kind of do the midpoint formula twice. Or we could have cut our slope, our unreduced slope, into a fourths. Again, let's take a look at that. So our unreduced slope for AB was negative 4 over 8. And so that's the giant step that goes from A to B. It's down 4, right 8. And remember, y is on top. X is on the bottom. Well, if I were to do a fourth of this step, a fourth of that, well, a fourth, negative 4 times a fourth, or a fourth of negative 4 is just negative 1, and a fourth of 8 is 2. So that means I need to change my y value by down 1 and my x value by right 2. And so that's down 1, right 2. Algebraically, I would take the coordinate of point A, which is negative 6, 3, and I can, again, change the y value by negative 1. Here's the mistake a lot of students make. We saw this when we were doing perpendicular slopes a lot of times. I'm going to apply these numbers to this coordinate, but a lot of people want to take the top number and put it here and the bottom number and put it here. That's not correct. Because a coordinate is x first, y second, but the slope is y on top, x on the bottom. That's why the bottom number needs to go paired with the x, and the top number gets paired with the y. So that's where that comes from. And then when I combine this together, I get negative 4, 2, which is what this point is right here, negative 4, 2. So for midpoint, you could use a midpoint formula where you could cut your giant slope in half. And for a fourth, you could do 2 midpoint formulas or cut your giant slope into a fourth. But what if it's not something that divides evenly by 2, like a half or a fourth? Like this next example says to find the point that's a fifth along the way. So midpoint formula is not going to be helpful here. So here we have to use that concept of what's the giant step, what's the big slope, and do a fifth of that. And they'll always tell you which point it's closer to, because there's a difference between a fourth of the way closer to A and a fourth of the way closer to B. A fourth of the way closer to B would be here. A fourth of the way closer to A is here. So we have to know which way we're going. And so they'll tell you, closer to C. So a fifth of the way along CD, and we could plot these just for a reference here. Negative 5, negative 6, that's C, and 0, 4, that is D. So a fifth of the way from C. So again, I want to figure out what is the slope of CD. And so that is 4 minus negative 6 over 0 minus negative 5. That comes out to be 10 over 5. And I want to keep that unreduced because remember, again, that's saying up 10 over 5. That's the one giant step. I know I could get there with a bunch of small steps, but one giant step is up 10 over 5. But I want to do a fifth of that. So I multiply these by a fifth. Top and the bottom, I do a fifth of each of them. And a fifth of 10, which is the same thing as 10 divided by 5, is 2, and a fifth of 5 is 1. This is my change in y and my change in x. So I need to change my y value by 2, which really means up 2, and my x value by positive 1, which really means right 1. So I'm going to do this from the point that is closer to C. So I take point C, and I change the y value by 2 and the x value by 1. And that gives me the point negative 4, negative 4. Which graphically I see that is right here. And this looks like it's a fifth of the way from here to there. The graph definitely helps, and you have a scrap graph in the back of the regions, but what if we don't have a graph? And what if we want to do it algebraically without the picture? This is where they'll use the phrasing directed segment. So find the point on the directed segment from this to this. That means this is the first point, this is the second point, and the first point is the one that we're going to be, closer to. So we don't need all that. we'll start off by the slope. What is the slope? So from this to this means this is my second point, again, my first point. So second minus first, 8 minus 0. It's y2 minus y1, second minus first. And 5 minus 1. 8 minus 0 is 8. 5 minus 1 is 4. And leave it unreduced. So I don't have a picture here, but I know the giant step here is up 8 over 4. And instead of doing that, how much of that step do I want to do? And this is where it gets a little bit trickier, is this time they're giving us a ratio of 1 to 3. Finding the point that divides the segment into a ratio of 1 to the 3 is not equal to 1/3. Okay? Think about it. If you had, 3 segments here, this would be a third along the way, right? This is 1/3. Well, that's a segment of 1 to 2 ratio. So it's not the same thing. So if you're given a ratio, you do need to figure out how much of it. Is it a fourth? Is it a fifth? Is it 2/5? Is it a seventh? And so on. And the best way to do this is think about 1 to 3. Make 1 on your point, and then 1, 2, 3. And then you see you have 1 out of 4 slashes. So it's the same thing as a fourth. The point of fourth down a segment splits it up into a 1 to 3 ratio. Another way to do that is you add the two numbers you keep the first number of the ratio, you keep that the same. And then you add the two numbers together, that's the bottom. And so that's what we're going to use for how much we want to change our slope by. So a fourth of these. A fourth of 8 is 2. A fourth of 4 is 1. That's what we're going to do to y. That's what we're going to do to x. And we're going to do it from the first point, 1, 0. Change the x by 1, change the y by 2. There's a lot of positive changes here, but they could easily be negative. And the answer then is 2, 2. So you got to be careful when they give it to you as a ratio to change it into the proper fraction, but of course we'll practice that. I'm sorry the video went a little long. And again, you could graph these on a scrap graph and make sure that it looks right, of course, and you have that in the back of the Regents exam. All right, that's it. See you.